So just briefly, just to introduce myself, I am a consultant on the professional services team here at LookR. My background is in data science. For the last 5-6 years, I've been working with large businesses in healthcare and retail, supply chain and logistics to kind of unleash the power of data science and kind of understand what it actually means in an applied setting. I know that one of the most popular searches on Google is how do you use data science? Right? It's a term that is very frequently used, very frequently probably misused. So what I want to do today, what I want to accomplish in this talk is a couple of things. One is to just kind of give a conceptual overview of where LookR fits into this sort of life cycle of being ready for data science. Talk a little bit about some of the high-level workflows. Obviously, if you've attended the lab, you've seen kind of a direct walkthrough of how exactly you can do a simple workflow with R. So I'll just kind of walk through at a very high level what some of those steps are. And then what I also want to do before I get into all of that is just to kind of do a little bit of a reverse Q&A. So what I want to understand is, for the people that showed up, obviously this is a very interesting topic for you, relevant to your business or to your clients. So what I want to just get a better sense of is, just by a show of hands to start, who here is actively using data science workflows either for their own company or for their clients? Okay. Of the people that raised your hands, keep your hands up, how many of you are using R right now? Okay. So you waved your hands pretty enthusiastically. What kind of use case do you have right now?
Definitely visualizations, ggplot2, dplyr, every tidyverse library imaginable.
So what kind of business case or what kind of business problems are you solving?
I think generally right now it comes to like good visualizations. A lot of times I can't make the same plots in LookR that I can in R, and if I want to do anything predictive, if I want to maybe do a logistic fit on a binary response, I can get that really easy in R, but I can't get that in LookR, for example.
Okay. What are some other examples? Thank you for sharing that. What are some other examples of use cases?
So I'm in operations, and I'm usually trying to track down a problem, and I could have 300 or 400 potential factors that could influence it. And so just to be able to hunt my way through those and pull them out, it's really helpful to move a big bulk of the data into R, churn it out there. And then once I've identified the problem, I can certainly dashboard that out for reporting and tracking. But it's like searching my way through that huge variable space is difficult.
Okay, that makes sense. Some other examples. Anybody else want to share?
Ooh,
in the back?
Brave soul in the back. I'm coming. This is my exercise for the week.
Yeah. And thank you guys for sharing your stories.
So we are kind of a payment processing system, and some of our clients try to monitor what will be their month-end chargeback count so that their gateways don't get shut down. So we kind of try to predict the month-end chargebacks for them using regression models, and we run that on R and get the coefficients into our dashboards.
Okay. That's a very cool use case, too. Any last folks want to share a story before I jump on in? Yeah. All the way in the front.
Oh, my gosh. Okay. Where am I going? Oh, all the way in the front.
So I run a lot of Bayesian models, and I try and understand what are the management factors that farmers can implement on their farms to increase profitability and meet their sustainability goals. And to me, it's all about interpretation. So I do a lot of exploration in R, but then I have to convey these messages back to the business users and back to the growers.
Yeah.
So I'm looking for a dashboarding solution to all the complications that I encounter back in the R world.
Okay. So resurfacing some of those insights back into LookR. So a quick question, sort of a second level question is, how many of you currently who are using data science workflows use LookR as a modeling layer? 2 people. That's very interesting. So that's going to be one of the core things that I touch upon in terms of building out this data science workflow. So keep that in mind. All right, let's see if I make sure this works. All right. Okay, so this is going to be familiar to those that showed up at the hands-on lab, so I'm going to touch upon this briefly. But one of the biggest and I think most important concepts to think about when you're relating data science to your use of LookR is this analytics maturity curve, where on the far left of this analytics maturity curve, you're basically standing up your data warehouse. You're moving from multiple disparate databases, Excel spreadsheets, et cetera, into one centralized place. And as you move right on that maturity curve, you start with, okay, what are we tracking? Getting on top of your metrics, starting to build more mature, robust reporting systems, getting on top of some simple statistical modeling. What does this actually mean once you have those metrics established? And then once you kind of get your foothold into that, then this last step is going to be what's going to happen tomorrow, sort of that predictive modeling. And so that's where some of the use cases that were mentioned are really going to come into the fore. So before you really jump into data science, I think it's really important to assess organizationally where you are on this maturity curve to understand, are you really ready to make effective use of data science, particularly in conjunction with your LookR instance. So to start sort of conceptually about sort of the why of data science, I think for me, the most important thing to really walk away with is this idea of, and I think this is a common saying among financial advisors, which is your past results are not indicative of future results. So without robust statistical modeling, the patterns that you see in your data may or may not be meaningful. And if you're only looking at historical data to make decisions, there's a lot of error that you're introducing and a lot of bias that you're introducing into the decisions that you make from your organization. So that's why data science is essential, because it essentially creates this discipline and this rigor that you have to start implementing in order to be very clear and pointed about what questions you're answering and how you're answering them, and proving, or at least building a theory that is testable, that can withstand some tests to kind of determine whether or not your hypothesis is correct. So from my standpoint, what data science is software plus statistics plus massive data sets. You might also include some data engineering and some ETL, because I think that you can't separate the data science and the analysis from the data that you're actually looking at. Again, you run into this garbage in, garbage out type of scenario. So your data definitely has to be in a place where it's ready to be used, and I think that's where LookR really comes in to be helpful to a data scientist. So I'm going to just sort of acknowledge up front that LookR itself is not a data science tool. However, a large part of what a data scientist does is cleaning, is acquiring, is pre-processing your data, is getting it ready to actually do analysis. You have to get to a point where you actually trust the data to be correct in the first place to be able to run models on top of that. So that is where LookR is instrumental, and I think completely, you can't do without it, I think, in a data science workflow right now. Now, what is doubly important is a lot of you, hopefully all of you at some point, are part of organizations that are already using LookR. So you already have some adoption within your organization, maybe not within your data science team, maybe your marketing team, maybe your FP&A team, whomever, but you already have some of these analytic maturity pieces in place in terms of data that you can trust, data that's reliable, clean data pipelines. So you already have all the stuff that you need to do ready and there for you as a data scientist. So now it's all about just getting that data out and doing what analysis you need to do with it. And more specifically, since there are a lot of different languages, technologies that you can use for data science, why R specifically? Now, part of it could be ideological. Part of it could just simply be, that's what you were trained in, that's what you have skills in. I think for me, a large part of why I prefer to use R, particularly when it comes to the research side of things, or just the initial prototyping of models or algorithms to actually use for these different types of analysis, is that it has one of the most robust libraries of statistical packages to use, more robust than Python. While Python has a lot of other benefits and lots of people use it, I think the depth in which you can go, it's very telling that most research happens. When you look at these research papers in economics and physics, et cetera, most of that research happens using R. And that's because of just the volume of available packages that you have to use. And it still, as an open source language, it's still very highly supported. Just because it's not the most popular doesn't mean that it doesn't have value. I think there's there's currency in a specific set of people using it very well as opposed to the whole world using it. But I think one other thing that I think it's really, really helpful, particularly if you're running sort of iterative experiments before you're automating everything, is that it's a function-based language as opposed to sort of a class-based or object-oriented language. That makes it very, very easy for someone that does not have a software development background to learn R and to get up and running to actually do stuff. So if you have the statistics background, and it's just a matter of kind of, okay, I just need a language so that I can, use software against these massive data sets because I can't compute all of that by myself. R is a perfect intro language to get started with, and it's powerful enough to scale to whatever size organization that you need. So some of the high-level use cases, I'm just going to have some examples. You guys have already talked some, so I'm not really going to touch into those use cases because I think you guys already have those. This was, just sort of things to think about or some cases, but it may not necessarily apply to you. So I'll just kind of jump past those. And kind of jump into the system architecture. So when we get into using R plus LookR, this architecture is very simple, right? You start with your data warehouse. In the hands-on lab, I used Snowflake, but I mean, it can be anything that connects to LookR. That part is not necessarily important. Just don't use Druid, I guess. I don't know. The next piece is your LookR deployment. So you have your modeling that's done in LookML, and then you're leveraging the LookR API to be able to pipe data out to your R deployment. So some of my recommendations for R deployment, some of these questions came up in the lab around sort of ensuring that you can handle large data sets. Is just to make sure that you beef up the GPU and the RAM on your server so you can handle whatever kinds of loads that you need. But essentially the structure is fairly straightforward. I like to use R notebooks. Part of what is really good about sort of a markdown file or a notebook is that there's also built-in documentation. So as you're doing your iterative experiments, you can hand this off to somebody else, and they can see exactly each step that you did, how you got your data, where you get your data, and ideally, if you're sort of descriptively or verbosely sort of commenting out what you're doing step by step, it becomes really, really easy to follow. And then if you would like to automate that, you have sort of the basis of documentation of what's actually happening. I throw that note out simply because it's so easy to build technical debt, especially with this kind of subject, especially because data science and the statistical modeling skills can be very specialized. So not necessarily everybody who is going to be touching this is going to be an expert enough to just be able to look at a function and know exactly what's happening. Same for any kind of code, but I think it's doubly important from a data science perspective because you're also trying to prove something specific. So there may be flaws in your methodology that you're going to want to expose to make sure that you get that right. So in terms of just like the basic workflow, don't worry too much about the slides on the screen. I'll talk through it and you can kind of see some pictures of code, whatever, on the screen. But essentially, the workflow is starting out with modeling your data within LookR, creating looks that represent sort of the data set with all the features that you want for your particular model or for whatever analysis that you want to do. I would recommend using derived tables. What derived tables enables you to do is ensure that the data that you're pulling with the API is the most up-to-date data in your database. Pulling from just an explore or a look can be sufficient, but if you, for example, are using data groups and you're caching your data in your look, you may not have the most up-to-date data, particularly if you're refreshing or the data refreshes inside of that cache period. It's a small thing, but once you start getting into automated processes, that could make a big difference in terms of what data you're actually using for your analysis. So the first step, again, is to build your derived tables that are going to feed the looks that you're going to point to. Then you're going to want to use the package called LookR. So this is an open source package. It's an SDK wrapper for R that was developed in-house at LookR by LookR engineers. It's part of our sort of LookR open source packages. There will be some updates to this SDK over the next 3 to 5 months. So kind of stay posted for that. Everybody that attended this, I will provide you with the same markdown document that I'm providing to everyone with the lab, so you actually see the step-by-step as just a template that you can use to get started. But essentially, once you have the LookR package set up, you will create an authentication token using an INI file that has all of your authentication details. So the URL of your LookR instance, your client ID, your client secret, optionally using whatever specific user ID you want to impersonate through the API. And then invoke your library, and then once you invoke your library, you can start building and training your model. So you'll load whatever library that you want to use, player, dplayer, et cetera. You'll also want to, in this particular case, I loaded a couple different sort of custom scripts for predictive R-squared as well as cross-validation. But at the very, very bottom of that, you see around line 44, I create a data frame that actually pulls data from a specific look. So we're using the API calls as you would normally with any other SDK to point to a specific look. You can also use run inline query with LookR, so you have two options of pulling your data. One of the limitations that we have right now with the SDK is that if you were to use specifically a look, you can't get around the natural row limit of 5,000. So if you have very, very large data sets, unfortunately right now you have to use run inline query. So you'll have to just sort of deconstruct the different query parameters, like what views you're using, what filters you have in place, what specific fields, if you have more than 5,000 rows, which is probably going to be every single case. So that's one of the updates that we're going to be having to this SDK to get past that row limit, so you can just point to a look, and then you can set whatever row limit you want. So that's upcoming. So you start building and train your model. In this particular case, I'm just showing you what I did with the LookR lab. It was a very simple workflow. I started with some exploratory data analysis, did a multivariate regression. In our case in the lab, it was taking house price information, or house price index data for house price changes by zip code, and making some predictions about what degree house prices are going to change in a zip code over a year. So a very super simple case. Used a multivariate model. Nothing spectacular. This is not about teaching everybody how to do a model, but this is more about, okay, pulling the data into LookR, doing some kind of analysis, and then once you have your analysis ready, you have your predictions made, or whatever analysis it is that you want to have, whether you're creating new variables, whatever it is, you then, once you're done with that, have the ability to then resurface all of that data back into LookR. So there are a couple of use cases that were mentioned where you did some analysis, whether it was customer segmentation, it was customer behavior, it was operational data, whatever that use case is, whatever it is that you're trying to resurface, you can then send that data back to your data warehouse. So there are a couple of different libraries you can use depending on the specific database technology that you're using. In the case of the lab, we were using Snowflake. So I had a dplayer Snowflake extension that allowed you to create a connection to your Snowflake instance, specify a specific database, and then once you're done, you can use a copy to command and send that data back into a new table within that database. So then once you're able to do that, then you can resurface that data back in LookR, create a new view, mash it up however you want. I guess what I should have done was provide links to those looks so you can kind of see what that looks like. And so I'll do that in the aftermath. When you get that R Markdown file, you all have those links as well, so you can kind of see that on the join instance and see what that looks like. So that's a very simplified workflow of getting data out of LookR, doing some analysis, building your predictor tables, and then sending them back to your data warehouse to surface those. There are a lot of more creative workflows that you can get once you do that. There's a lot of opportunity for automation. And in the first lab, there was one client that had a really, really cool case of doing some real-time, basically doing some input fields, a look that has an input field, doing some kind of changes to demographic data, and then seeing how that impacts the prediction for that particular customer. So you can do lots of really cool things. Really, my goal here is to kind of put the spark for you guys in terms of, okay, how can I actually make use of LookR in these workflows, and then share it back with business users to actually make decisions. Because realistically, the business users that you're sharing insights from your modeling aren't going to be super concerned about the same kinds of things that the scientists building these models are going to be concerned about. What they're going to be concerned about is, hey, I need a prediction that's accurate. Right? Does this actually work? Prove that you're worth what I'm paying you. Make this work for me. So being able to present that back in a platform that people are already using for BI is going to be really, really valuable. So like I said before, the opportunity with LookR is that you have a surface where you already have data that you can trust, that your organization already uses, that's already cleaned and pre-processed for you. So that makes it a lot easier for you to start those data science workflows, rather than having to find everything yourself, clean it up yourself, and do all that work, and you have all of your data in a separate silo. The plus side is, if there are data elements that you do need to bring in to combine with what your team already has, there are some really, really nifty ways that you can do that. Like I said, I showed you the dplayer Snowflake package. There are a couple others. There's one for BigQuery. I think it's BigR Query. There's an RJDBC library that allows you to connect with pretty much any SQL dialect, including Redshift. So there are a number of different options you have around surfacing data that you need and combining it in your central repository, and then doing creative things even within LookR to surface and present what conclusions you've already drawn or information that's useful for your end users. So I think that's sort of workflow in a nutshell. Like I said, you'll have a markdown file that has an example or a template that you can use if you so choose. So I guess I'll set that aside. I think the next piece that I really want to cover is sort of understanding key personas for knowing when you are actually ready. So I talked about the analytics maturity curve earlier, and I think this next piece is really about sort of what do those personas look like from a human or organizational standpoint. And there were sort of 3 high-level ones that I picked out. Obviously, this is not an all-inclusive list. I think there are going to be other use cases that you have that will also present opportunities for implementing some of these workflows. But the first is for people that are using the LookR API, specifically for embed or for powered by LookR types of use cases. So I'm talking about people that you may be surfacing data to your customers already around what their customers are doing. I have one client that works with pharmacies across the country, so they have a lot of clinical data that they're going to share with their pharmacies. They have a lot of drug supply data that they're also sharing. So that presents a lot of opportunity to do some really cool predictive stuff around understanding when to do resupply, understanding in terms of costs, how do you minimize costs, how do you maximize revenue, things like that. So that's one sort of really good, interesting persona that we found is ready for data science because you already have all those sort of foundational pieces in place. The second one is you're a company or organization that has a mature data pipeline and you have really mature reporting use cases. So you're already past the point of getting all your data in a warehouse. You're already past the point of setting up those initial looks, getting used to building out these metrics. So you already have some level of adoption of people building dashboards and using LookR for sort of regular BI, more traditional BI types of applications. So once you're at that point, I think you're ready to start asking some of those questions about, okay, so how do we predict X? If we have a customer that has these demographics, what can we say if we have this new promotion? What is their likelihood of interacting with this? If we have a certain type of product, what are good loss leaders that we can use to get people in the door to have second and third purchase? What are some of those patterns that we can find there? So that's a second sort of key persona. And a third key persona is that you already have an internal demand for predictive analytics, i.e. you already have a data science team, a mature data science team, and this is an opportunity to use sort of a really mature data set that's already built out, or you're a data science team that's struggling to prove yourselves within your organization. How can you get some quick wins using data or using sources that your executive team, your marketing team, your finance team, et cetera, already trusts? So those are 3 sort of high-level good use cases, or personas rather, that are good candidates for starting with these sort of workflows that I've talked about. Obviously, there are a lot more than that, and we kind of heard from some of the people in the room about some of these other use cases that are interesting, that are useful and ready for this data science.